Welcome to Trikana Skill, your lifetime career partner. Trikana is a pioneer and trailblazer in the field of civil engineering and construction training, seeking to bridge the gap between engineering studies and the construction industry. Direct shear test on soil. Objective: to determine the shearing strength of the soil using the direct shear apparatus. Need and scope. In many engineering problems such as design of foundation, retaining walls, slab bridges, pipes, sheet piling, the value of the angle of internal friction and cohesion of the soil involved are required for the design. Direct shear test is used to predict these parameters quickly. The laboratory report covers the laboratory procedures for determining these values for cohesionless soils. Shear strength. Shear strength is a term used in soil mechanics to describe the magnitude of the shear stress that a soil can sustain. The shear resistance of soil is a result of friction and interlocking of particles, and possibly cementation or bonding at particle contacts.
Apparatus. Direct shear box apparatus. Loading frame, motor attached. Dial gauge. Proving ring. Tamper. Straight edge. Balance to weigh up to 200 milligrams. Aluminum container. Spatula.
Knowledge of equipment. Strain-controlled direct shear machine consists of shear box, soil container, loading unit, proving ring, dial gauge to measure shear deformation and volume changes. A two-piece square shear box is one type of soil container used. A proving ring is used to indicate the shear load taken by the soil initiated in the shearing plane. Procedure: check the inner dimension of the soil container. Put the parts of the soil container together. Calculate the volume of the container. Weigh the container. Place the soil in smooth layers, 10 mm thick. If a dense sample is desired, tamp th soil. Weigh the soil container. The difference of these two is the weight of the soil. Calculate the density of the soil. Make the surface of the soil plane. Put the upper grading on stone and loading block on top of soil. Measure the thickness of soil specimen. Apply the desired normal load. Remove the shear pin. Attach the dial gauge which measures the change of volume. Record the initial reading of the dial gauge and calibration values. Before proceeding to test, check all adjustments to see that there is no connection between two parts except sand/soil. Start the motor. Take the reading of the shear force and record the reading. Take volume change readings till failure. Add 5 kg normal stress 0.5 kg per square centimeter and continue the experiment till failure. Record carefully all the readings. Set the dial gauges 0, before starting the experiment. Figure shows different dial gauges from where the values are recorded. Data calculation sheet for direct shear test. Applying normal stress of 0.5 kg per square centimeter and note down all dial gauge readings and calculate the shear stress by dividing the load on proving ring by area of cross-section of specimen. Repeat the same procedure and calculate shear stress by applying normal stress of 1 kg per square centimeter. Now perform the same procedure and calculate shear stress by applying normal stress of 1.5 kg per square centimeter. Result: shear strength of soil is calculated.
Thank you for your time. If you have any queries, do not hesitate to contact us.